Hello, Mohammed. My sound is clear, beta.
Yes, sir.
Shall we start? We are already completed the half part of the unit, and we will taking extra some lectures due to the vast syllabus, and we will cover the basics of basic part of the fluid mechanics and some dimensional units. So very good morning to all of you. Myself, Professor Dr. Mirza from Car Technical Campus. So we will look after a few formulas we are seen in the your unit number one uh, for the properties of fluid. Okay, so number six. Today is 8th September, I think so. Okay. So first, you know some basic units, desired units from the basic units. So we will uh, write down. Right, you are also write down. Please sit with the pen and paper. Okay. So we will write down first velocity. Velocity v. Generally, we are measured in SI unit is meter per second, and its dimensional unit. If you write length meter for length per time, second is in time square. Time raised to 1 meter per second is the SI unit for the velocity. Second, acceleration. Acceleration. Generally, we are denoted by the small a, and it is measured in meter per second square. And if you write the dimension, it is LT minus uh, raised to minus 2, because it is meter per second square. Okay. इतना बोलने के बाद भी आप लोग लेट ज्वाइन होते हो. Try to join earlier. So this we are writing on the derived unit from the basic units, and these are very important to remember. Uh, like the pressure. Pressure generally it is measured in Newton per meter square. Okay? So it may be right. It may be if you write the dimension of this is mass kg is also there, L raised to minus 1 and T raised to minus 2, because you know that Newton is equal to, write to Newton, Newton will be the, sorry, write on force. Force is measured in Newton. Write down force. The SI unit is Newton. And if you see, one Newton is equal to kg into meter per second square. Okay. meter per second square. Meter per second. Meter per second square. Wait a minute. So it is uh, mass into acceleration. Generally, force we are measuring uh, mass into acceleration. Mass we are generally measured in kg and action meter per second square. So that's what the dimension of if you write the mass in kg, meter in L, t square and t raised to time raised to minus time raised to minus. Okay, now if I will write down another one, the density we are measured in kg per meter cube, kg per meter cube. If you write down the dimensional quantity for this is mass and L raised to minus 3. Similarly, specific weight, specific weight it is necessary for solving the problem. That's why these are writing. Okay, you should also write down this name so that you should know that. The specific weight it is measured in Newton per meter cube. Newton per meter cube, and its dimensional quantity is right m L raised to power minus 2 t raised to minus 2. Okay, and 7 to write down the viscosity. Viscosity we are generally denoted by the mu. It is measured in Newton second per meter square. To write down the dimensional quantity for this n L raised to minus 1 and t raised to minus 1. Okay, 8 to write down the energy or work. Energy or work. The unit of energy is nothing but the joule. It's generally written as joule, but 1 joule is equal to it is generally Newton meter. Newton meter, and its dimension is m square t raised to power minus 2. So you may also find out, like for force I have find out dimensional quantity. Okay, kg is nothing but mass, meter per second square is the acceleration. The acceleration is l t raised to minus 2. That's why m l t raised to minus 2 is the dimensional quantity for the force. For the energy for viscosity you can derive from that previous quantities. Power generally we are measuring in the watt, and if you write down that is Newton meter per second. Newton meter per second. You write the dimensional quantity for the watt power. It is ml square t raised to minus 3. T raised to minus 3. So that is the some derived unit. And you know that the gravitational acceleration for the Earth is, we are generally consider as 9.81 kilometer meter per second square. Meter per second square. Okay, so that should be. So these are some basic units, and now we will solve the example. Uh, so first, write down example number 1. You have to open your before going for the example. I will revise the formula also for first unit. Formula for first unit are, you have seen the density, mass density, or simply you can say density. It is measured, it is denoted by rho. Rho is equal to m upon v. M upon v, and its unit is kg per cubic meter. Okay. Number 2, the specific volume is nothing but volume per unit mass. Volume per unit mass, that is, it is denoted by nu. The Greek word nu. Nu, it is equal to V upon m. That is nothing but 1 upon density, 1 upon rho. Okay, and it is measured in meter cube per kg. Okay, write down all this formula. It is very important. Then specific gravity, that is Sg. It is nothing but density of substance, any substance, divided by density of your water. It is also called as weight of substance in a water. Okay, specific weight. It is generally denoted by the gamma. I am going fast because already we have covered all these things. Just for sake of you, I am writing this. Rho into g, when g is the gravitational acceleration, and its unit is Newton per cubic meter. Fifth, the mu, that is nothing but called as dynamic viscosity, or simply it is called as viscosity. It is nothing but mu is equal to tau upon du by dy. So it is nothing but shear stress. The tau is nothing but the shear stress, and it is the velocity gradient. So mu is the coefficient of dynamic viscosity. And simply it is called as viscosity. So shear stress divided by rate of shear strain, Okay, change in volume to original volume is nothing but rate of your shear strain, and if you write down that is Unit of this is nothing but it is measured in a poise. So it is measured in a poise. The unit of this is Newton second per meter square. Newton second meter square. It is generally 10 poise. 10 poise. And one poise is equal to 100 centipoise. One poise is equal to 100 centipoise, and it is in CGS system. The CGS system, it is dyne second per centimeter square. Okay. Now, 6. We also seen the kinematic viscosity. Kinematic viscosity is the ratio of mu to the rho. Rho is nothing but your mass density. And the unit of kinetic viscosity is meter square per second. Meter square per second. And in CGS system, it is centimeter square per second. In CGS system. Okay. And it is measured in the stroke. It is measured in the stroke. And one stroke is equal to 10 raised to minus 4 meter square per second. Is to 4 minus 4 meter square per second, and one stroke is equal to 100 centistroke. 100 centistroke. So power is shut down. Maybe our lecture will be disturbed, but we will continue next lecture if this lecture is disturbed. The power is gone in college. Whatever it may be covered, we are covering. The backup is very low, and then bulk modulus we have seen yesterday. These all are the formula for the properties of the fluid. That is nothing but minus dP, change in the pressure to the dV upon V. Already we have discussed this also. Change in pressure to the change in volume to the original volume is the stress. And bulk modulus is nothing but, if you write down stress, then pressure is nothing but stress upon strain. That is the K. We are denoting by the K. I will go for the example. Write down example. If time permit, we will continue. Otherwise, if it is shut down, the power backup is shut down, then we will continue this example in next class. There are two parallel plates. Write down the example 1. There are two parallel plates at a distance. Battery is very low. Oh, it's gone.